Hey there, welcome to yet another episode of the Blockcrunch podcast, and another episode in the 500 Blockcrunch mini-series, where I, Jason Choi, partner with seed investor 500 startups to bring to you a series of interviews with some of the most exciting scalability projects in the world of blockchain and crypto today. And in this episode, we have Emin Gün Sirer, Associate Professor of Computer Science at Cornell, to discuss something that not many people seem to be paying close attention to when they discuss blockchain scaling, and that's the networking relayer level, or layer 0. Now, one project that Professor Sirer is a co-founder and chief scientist of is bloXroute Labs, which we will discuss more today. Now, in this episode, Professor Sirer and I dive deep into what layer 0 actually is, how it fits into layer 2 scaling solutions, like the many projects that we've discussed on this show before, as well as the specific architecture of bloXroute and how its tokens work. Professor Sirer is one of the most vocal and early proponents of cryptocurrencies, so I'm incredibly honored to have him on the show and discuss with me today. So without further ado, let's dive right in.
This is worldwide phenomenon.
Welcome to the show, Professor.
Very nice to be here. Thank you for having me.
Now, you have a very long resume. bloXroute CEO Uri Klarman says there's pretty much no one else in the world that rivals your expertise in crypto. And you have been named as Brilliant 10 in the Popular Science magazine and are often credited as one of the earliest movers in the crypto space, even predating Satoshi Nakamoto. Now, just to give our listeners a taste of your resume, you predicted the DAO hack, you worked on sharding blockchains, you led a team that built the Falcon Relay Network, which we'll talk about later, and you also served as expert witness for the Mt. Gox case, in addition to leading pioneering projects like Avalanche and bloXroute, the latter of which we will discuss today. So I'm interested, how did you first get into cryptography, and what were the major drivers behind you dedicating your entire life to this space before the word Bitcoin was even invented?
Yeah, that goes back to 2001, 2002. And I was working on peer-to-peer systems at the time. And the main application then was file sharing. And in file sharing applications, you have this problem known as leeching. People would take things and not put back things. So they would download files and they'd be nowhere to be found when you needed to download yourself. You need someone to upload. And so that problem known as leeching was a significant one. And unbeknownst to me at the time, Bram Cohen was developing this thing called BitTorrent, where essentially peers engage in tit for tat. I give you a block if you're going to give me a block. And so I considered the tit for tat idea, and then I thought, well, this is kind of like barter. And why don't I skip this step? And why don't we build something where I give you a block, and in return you pay me in some virtual cryptocurrency. Right? We didn't know the word cryptocurrency at the time, but the resulting system is a system that has proof of work for minting. There is absolutely no centralized bank and no centralized tokens, and the peers then exchange blocks and get these tokens in return, and the tokens themselves are called karma. And karma was a very interesting system from an academic perspective, and the unfortunate thing about it was the timing was absolutely horrible.
It was right after 9/11.
Right after 9/11, it's just absolutely terrible. Everyone was really up in arms about terrorist financing. So if you went to them and said, "Hey, I'm going to have a new token to take over the world economy, and there's going to be no controls over it," that would have been the death knell for a young assistant professor at the time. So it's very well cited, and I did not pitch it to the same the community that Satoshi pitched it to, and Satoshi had the benefit of the 2008 crash. So he got a lot of things right. Also, of course, let's not forget, Satoshi did have a much less fragile, much cooler consensus protocol compared to what I was using in Karma at the time. So he certainly got certain things down pat very, very well, and also ended up getting very good on the timing and on the sort of the opportune world circumstances side.
Now, for the rest of this interview, I'd like to dive deep into the architecture of bloXroute and the challenge it is trying to solve, its token utility, as well as the practicality of the solution. So let's start with the general first. bloXroute is attempting to reduce block propagation time. So can you explain to our listeners what is the issue with block propagation and why is it a bottleneck for scaling blockchains?
Sure. I think the sort of the highest level thing that bloXroute is trying to do is it's trying to get information from people who have it to people who need it. So that's really the mission of the company. I think of bloXroute as an Akamai of sorts. Akamai's job when it emerged, as you know, listeners might be young and they might not know the internet history, but the internet came up and you know, everybody was downloading things, and Akamai came in and said, look, this is going to be big. And when it's big, somebody has to be in the middle to help facilitate transfers. And so Akamai came to be. And Akamai's job is to help facilitate bulk transfers, things that are not very timely. Typically ends up sending you video content or maybe web page content, but very much not financial data. So bloXroute is there to fill that gap. We believe that this next generation of systems are going to be very, very big. They're going to transform finance for sure, and we believe they're going to transform essentially all of commerce as well. And there will be data in the hands of people that other people want to get a handle on as quickly as possible. And so a low latency transmission network for such data, typically financial data, is what bloXroute focuses on. Now, the block propagation issue is an instance of this general problem. We're going to see this problem come up again and again in different contexts, but certainly it has come up many times in the context of cryptocurrencies. So let me try to explain what this is. I think a lot of listeners might be familiar with this concept of mining, and I think they probably understand. A lot of people I've come to realize don't really understand mining and the games behind it. It's actually very subtle and very, very nuanced and complex. But there is something interesting going on there, and that is the miners are working head to head in a race to come up with the next block. And every now and then somebody gets lucky and finds that block. And now there is another kind of a race to get that block in the hands of all the other miners as quickly as possible. And so that's sort of the setup given to us by Nakamoto and every cryptocurrency in the Nakamoto family. And so to do this properly, or to do this at all successfully, you need a fast network. The slower you are at transmitting your data, the more at a disadvantage you are. A miner is held back and will lose money if it takes a long time to propagate the blocks. And if you get rid of all of the other overheads associated with the consensus protocol, if you get rid of all of the CRUD, all of the extra layers of software communication and so forth, you transport yourself to a world a year from now, or a year and a half from now, where we've really shed off the fat, then the thing that will actually limit consensus protocols is going to be transmission latencies. The ultimate bottleneck, if we are doing our jobs right at the consensus layer, the ultimate bottleneck needs to be and will be necessarily end up being in the network layer, the transmission layer. That's what takes the time to get that block from Shenzhen, China, to Estonia, or to wherever else, Iceland, to wherever else the other miners might be. And doing that effectively, doing that super fast with low latency is good for everyone. It evens out the mining field. It makes the fellow at Iceland with his farm competitive with the fellows in Shenzhen who are located together and have quicker access to each other's blocks. So any kind of a technology to even out the field is actually good for all of the existing proof-of-work cryptocurrencies, and it's good for the participants.
So a little history for our listeners. bloXroute is, of course, not the first propagation system built for blockchain. There have been existing solutions like the Bitcoin Fast Relay Network, which uses multiple gateways around the globe to reduce block propagation time, which was then replaced by Fiber, which uses fiber optic wires to further reduce latency. And lately, we also have the Falcon Network, which your team worked on. And Falcon Network uses something called cut-through routing. In other words, these relay nodes relay the first bytes of an inbound block as soon as they come in, instead of waiting for the whole block to come in, which of course further reduces latency in a blockchain. So my question to you is, how is bloXroute different from all of these previous iterations, and why is it an evolution from previous solutions?
Sure. So Falcon started out because Matt Coralla, who had built the Bitcoin Relay Network, said, well, he was going to shut it down. And we thought, okay, well, he might indeed shut it down. It's kind of a problem that this network is being run by one person, and it's not a commercial operation. And So that got us interested in the topic, and then once you think about the whole way in which these things ought to be structured, you realize the Bitcoin relay network isn't really the best way to structure these things. And in fact, the protocols that people have typically used in this entire space are all not the most optimal way of doing things for getting information from the sources to the sinks. Why not? Well, they always do the same thing, and that's sort of, there are these like blind spots that developer communities develop. They inherit something and then they just repeat it, just without thinking, whether or not it can be redone in a different way. And the thing that they do is, they create a network, an overlay network, which is fantastic. There's nothing wrong with that. And then when it's time to propagate the data, every node receives a packet, checks the packet, verifies it in full, and then after that laborious process, sends it on. And so our first take at this was, well, can we do this better? So if we are talking from one node to another and both nodes are under our control, then there's absolutely no need to redundantly check the validity of a block at two different locations. We just need to do it once. And we can do that validity checking in a lazy fashion. So that suddenly took us from where we used to be, which is a very slow, laborious process, where if you were going to traverse n hosts, some n being some number, and it would take n times d delay amount of time, we could suddenly cut that down. We could cut it down from that to just 2d, right? So we get the packet, we check it once, and then we send it to its destination. It gets checked again. The number of hops we go through is immaterial. And this is, we essentially reused an idea from networking literature that had been applied in the construction of high-speed routers, known as cut-through routing. Today, if you send a packet, especially larger packets, across the globe, none of the routers involved will do what Bitcoin does today, which is they never receive the packet in full, laboriously do things on it, and then send it on. They're not store and forward routers. They do cut through routing. So that happens at the physical network layer, and Falcon, and now bloXroute, carries that same concept to the overlay layer. So the overlay nodes start transmitting data as soon as they receive the data. That way, the transmission is sped up by a factor of n. We don't often see these kinds of speed ups in networking. Typically, people are happy when you get, a 5%, 10% sort of eked out hard-won gains in terms of latencies. But rethinking how that's done can give you an enormous advantage. So, which is what we did with Falcon.
Now, we're definitely going to come back to that point later. But first, I'd like to take a moment to touch on off-chain scaling solutions like the Lightning Network, like state channels, sidechains, which we have discussed on the show before. So with so much development happening in layer 2 already, why focus on layer 0? Why focus on the network relayer level?
So that's a good question. So layer 2 is a great way to scale coins up. I worked on layer 2 also. I have we did the work on T-Chain, T-Chan, the two systems that are sort of, they build on each other. T-Chain builds on T-Chan. And we use secure hardware to greatly speed up, essentially, layer 2 networks like Lightning. T-Chan is essentially Lightning with the aid of secure hardware. And we ended up getting, I think we have the world's record on fastest payments, right? So we were doing 125,000 transactions per second across the Atlantic. So from London to Ithaca. So those solutions are wonderful. They will bring us scaling. They'll allow us to open up great efficiencies when there are people who transact frequently. If you and I are in frequent sort of economic relationship, or I pay you and you pay me back and so forth, those are the kinds of situations where these systems can win. For one, I don't think that we can rely solely on these systems for scaling, for the reason that there aren't that many situations where me and someone else are frequently interacting like this. There are some scenarios I can identify between exchanges. This happens a lot, and they should be using layer 2 solutions. But when it comes to regular users, there really aren't such entities other than banks. And so I can see a world where we replicate the existing system, where people are dependent on banks to offer them service. getting duplicated using Lightning Network, for example. And that world doesn't seem so compelling to me. I don't want Bitcoin users to have an on-ramp. I don't want them to have a watch guard or a watchtower, whatever it's called, to check the state of their channels and so forth. So there is that worry and concern in terms of centralization that these networks might then pose. I suspect I'm not the only one with this concern. And so if you take away that vision of let's replicate the banking system using Bitcoin, if you take that away, then what you're left with is a layer 2 solution that's great for inter-exchange transfers, but potentially not so great between people. The capacity of the Lightning Network has never been measured, has never been simulated or studied extensively. And if studied extensively, I suspect that there's a conjecture, of course, but my conjecture is that the capacity might not really be there. There is also a secondary issue that even if the capacity is there, in all layer 2 solutions, there's a fundamental trade-off between privacy and efficiency. You want to use as short a route as possible between you and your destination. If you use longer routes, it's bad for the network because you consume the sending capacity of the network. So you'd like to discover paths, monetary paths, these are. So you'd like to discover monetary paths between yourself and your destination that are very, very short. Now, to do that, you need to ask questions, right? You need to ask a question like, can I route 10 BTC over Professor Sirer to Eleni, right? And so that's good, and that's a fine thing for you to ask, and I can say yes or no. But the answers I give to you reveal something about what other things Eleni might be doing. In particular, if I've routed money over the same route for somebody else, she's received payments recently, then I might say yes, 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 and suddenly turn and say, no, I'm sorry, I can no longer let you route 10 BTC. So that will tell you that somebody else recently routed a substantial sum from me to her. And this problem is not going away. We never solve this problem with internet routing. It's just that internet routing isn't as privacy sensitive. So this particular routing trade-off is very, very difficult to solve. And so that's why, I have a lot of reservations about layer 2 systems, even though I worked on, I believe, the fastest one. They have their uses, they have their application scenarios, but I can't imagine that they would be a good idea to deploy at scale for all of the world. I think that would lead us back to the hands of bankers, centralization, and in a world where people are monitoring each other's financial activities, and I would find that a highly, highly disconcerting outcome. So for all these reasons, I think the chain itself has to scale. But even if you don't believe any of this, and there are people there, sadly, this whole area has become really politicized. And so the people are putting lightning marks in their names on Twitter and so forth. This is, you've left the territory of let's have a rational science-based conversation to let's just sort of take a flag and wave it and try to make the other people shut up kind of a scenario. That mob mentality, it'll work in the short term. If you look at the people who kind of encouraged it, nothing good has happened to them over time. So I don't believe it's a good long-term strategy. So anyway, there are people who love Lightning and who have identified themselves with this whole vision so much that they have to believe it's great, and they can't even accommodate, even for a microsecond, any doubt whatsoever about its future. Fine, they bet the farm on it. That's fine. The issue, though, is even if you go to that world, even if you say, okay, everything that Professor Sirer is saying is FUD, and he is sort of, I don't know, making things up or whatever. Like, these people say all sorts of things. They're free to say any of these things. But whatever. So the privacy situation will be solved. The capacity will be fantastic for reasons, right? So I'm going to leave a particular, word there. It looks like it's unknown. But, let's assume everything's going to turn out great. It's all going to be sunshine. Even then, the chain has to scale to allow the layer 2 to scale. We all need the chain to be able to accommodate a large number of channel closings at any one time, or else there are all sorts of attacks on layer 2 protocols. So absolutely, it's absolutely essential that we get scalability. We tackle scalability at every level of the stack, and when you do that, you find that the network is the primary bottleneck.
Now, let's go deeper with this. My understanding is that bloXroute alone is not a scaling solution, but rather it allows for cryptocurrencies to enact simple scaling solutions. In other words, bloXroute is a way to enable cryptocurrencies to implement simple parameter changes to the blockchain that increases throughput without the unintended side effects of unintentional forks that could otherwise unravel a blockchain. So, in other words, in order to actually enjoy the benefits of bloXroute, a cryptocurrency has to either increase the block size to fit more transactions per block, or reduce the interblock time interval to produce more blocks in the same amount of time. Now, I know you've done a study on Bitcoin block size increase and decentralization, and it's been a hot debate in this space. So my question to you is, for the cryptocurrencies that run on bloXroute, since you make it easier, much easier for them to increase their block size to say 1 gigabyte and enjoy incredibly high throughput, isn't bloXroute in a way incentivizing miner centralization?
Absolutely not. That's the entire point of bloXroute and other strategies like this. That as you make the blocks take less and less time to be transmitted from a location to another, you even out the playing field. So you take away the advantage that people had to build it on their own blocks. You take away the advantage that people had to build on the blocks of people who were nearby, because it becomes so much quicker to send the blocks from one location to another. And so coupled with other technologies like block compression, bloXroute gives you that nice even playing field, and you can contemplate making really, really large blocks, or tweaking the parameters like block frequency to get at much higher scales.
So let me qualify my statement a little bit, because I would really love to get your thoughts on this. And for listeners who might not have an understanding of the block size debate, essentially a popular argument that the crypto world levels against bigger block sizes on blockchains is that it leads to miner centralization. And simplistically, the way that this happens is, if you increase your block sizes, you're increasing the size of the blockchain dramatically, and hence you will require more powerful and hence expensive hardware to store the blockchain. And as the argument goes, small miners cannot afford these increasingly expensive hardware, and only big mining farms and corporations can, and hence mining will be centralized. The power to mine will be centralized amongst the hands of big corporations or mining farms. And my question to you is, since bloXroute makes it a lot easier for cryptocurrencies to scale by increasing their block sizes, doesn't it also make it easier for cryptocurrencies to have miner centralization?
So that sort of boat of trying to mine on small devices, that sailed a long time ago. That boat sailed in 2012. So these people typically play funny games where they do a gish gallop, which is like they rattle off like 15 different things, hoping that they will overwhelm the listener and that the listener will not be able to put them all together at the same time. So what does the gish gallop involve? Well, it involves saying things like, well, I want to support small miners. Okay, if you do that, then there's an immediate thing that people will ask of you, which is define the smallest platform you want to support. Define it. This is not even, like, I'm not actually questioning anything that these people are saying. I'm just saying, okay, look, if you say that, then the next thing you have to say is, like when you buy software from Microsoft, it says minimum required platform. So now you need to define your minimum required platform so that we all can have an intelligent discussion. And then they suddenly start doing some kind of a funny dance. And I've never heard anybody talk about the actual minimum required platform. Because if you do, then you start to find out interesting things, which is, well, that minimum required platform, like whatever it is that these people want to sort of target in their minds, it sounds good to target a small device, right, for mining. The small device has absolutely no hope whatsoever of mining, right? So the smallest miner you can buy, which is something that I just bought recently, an ant miner, it cost me like $600 or so. And that pales in comparison to the disk. For $50, I can buy a 4 terabyte disk right now. So the amount of storage I'm going to need is absolutely, nothing. It's just not even a rounding error in comparison to what you actually need to buy to actually mine. These mining chips are very expensive. Mining rigs, space-wise, energy-wise, cooling-wise, these are non-trivial expenditures. And the little bit of storage that you might have is absolutely nothing. Now, then the next thing that they will say is, well, okay, well, what about the non-mining nodes that want to validate the chain? Well, okay, so then what about them? Again, define your platform. Let's talk about it. So certainly your Mac laptop that I'm staring at right now, which is in front of me, is perfectly capable of handling a terabyte per year kind of a workload, which is not all that much. These are not large numbers. So. This is a game of narratives at this point. It's become a politicized political game, and so people throw out a whole lot of things that sound good, but none of it, absolutely none of it, folds into a coherent intellectual framework. When you talk to them and you say, write these arguments down and make an argument like a proper argument, they are not there to do that. And so I've tried to do this many years ago. I tried to do it on the devs mailing list and so forth. I realized that the game was highly politicized. I don't really have much to say to these people. I think it's fine, If you want to do what you want to do, that's fine, right? If you want to direct fees to a different layer, that's okay. Do it. That's fine. At the end of the day, you're going to turn around and find that the network is always going to be a bottleneck, and we are there to do things that help. And people are free to use us or to steal ideas from us, which certainly happens quite often. So either way, it's an exciting area. There's going to be a lot of different players in this area. And I suspect that bloXroute has a large role to play for any currency or any system that relies on quick transmission of important, expensive, timely data.
Now, for the rest of the interview, I'd love to focus on the architecture and token of bloXroute because the white paper is utterly fascinating to me. So can you talk a bit about what the architecture is like?
Right. There are two things I think we should talk about, which I'm really excited about. So we already talked about the sort of the overlay structure of bloXroute, the core idea that allows us to get data quickly to its destination. There are many other ideas like that in the implementation. So there's all sorts of interesting compression ideas as well as others. But okay, let's talk about the rest of the system. So the way the bloXroute token is constructed, I think, is really, really interesting. The dynamics are really, really novel. So the way you're supposed to use bloXroute is as follows. When miners adopt into bloXroute, they give a percentage of their fees into the bloXroute, what I would call the kitty, into the big bloXroute holding pool. And so every time they process a transaction and issue a block, then that block has some donation or has some payment going into bloXroute. The bloXroute tokens are rights on that particular holding pool, on that kitty. So by holding bloXroute tokens, what you're essentially doing is having the right to collect from this fund that grows over time as people use bloXroute itself. And so in an odd way, then bloXroute tokens and this whole kitty thing operates kind of like a fund of sorts, where it sort of gathers money the more the system is used, and the bloXroute tokens themselves then issue payouts depending on how much what percentage you hold. So this is really interesting. If you wanted to track the usage of currencies, if you wanted to buy a collection of currencies that are the most used, so then the bloXroute token would be a way to get at that elusive index, because it would grow as currencies use bloXroute, and thus be correlated with the currencies that are the most used that have opted into bloXroute.
So for our listeners who are interested in learning more about the bloXroute token, it is essentially an ERC20 token whose sole purpose is to be a vehicle for investment in bloXroute and a way to distribute 50% of all cash flow that bloXroute receives. So where this cash flow comes from is actually a 10% transaction fee on top of any mining fee. and is completely optional, at least at the early stages of the project. So my question to you, Professor, is why only distribute 50% of all the cash flow? Why not all of it?
The rest, of course, it's 50% because that's the sort of the part that corresponds to the token holder's share. The other 50% goes to the day-to-day running of the network itself. So the network is actually quite expensive to run because it requires dedicated hardware, dedicated lines, and dedicated people to keep the software up and to provide improvements.
Now, bloXroute itself also has extensive mechanics built into it that maintains neutrality. For instance, propagating blocks without knowing what's actually in the block, so they can't censor these blocks based on the content, and not knowing the IP addresses of the nodes propagating the blocks, so they can't selectively censor certain nodes they don't like. So can you talk a little bit about that?
Right, absolutely. I forgot to mention this before. So that's a really interesting feature of the entire system. So as I mentioned, we talked about the transmission, but there's one additional part to bloXroute. So if all you did was a fast network, then it wouldn't necessarily be very compelling for people to adopt, because then you're in charge of that network. They might be reserved, and they might say, well, look, I would buy into it, but I don't know what you will do to my packets. What if you selectively censor them? What if you XYZ, right? So you can have all sorts of questions about anything that's managed by a central entity. The bloXroute network is designed such that it is incapable of engaging in selective censorship. The packets it routes are packets that are opaque to it. It doesn't know the contents of the packets at the time it's routing them. And the revelation step happens at the end after the packets have reached their destination. And that, of course, helps even out the playing field. But much more importantly, it also helps people have faith that they are not beholden to us, that our hands are essentially tied. In what we can do. We cannot discriminate on the contents of a block or a transaction just because we can't see it. It's very, very simple. The API prohibits us from having that kind of control, and that's a very, very convenient place to be. And essentially what you're seeing here is the emergence of different layers. And unlike proper traditional networking, I think it's essential in this world for layer 0 to be agnostic, to be sort of neutral, to be value-free, or whatever you want to call it. The bottom line is it should be incapable of doing harm. And that's exactly how we designed bloXroute.
So in your opinion, in the long term, what are the biggest risks and opportunities for bloXroute?
So there's quite a lot once we go, so there are a bunch of things that we need to do ahead of us. So the very first thing that we tackled, the thing that's under our belt that we've been doing for the last 2 years with Falcon and now bloXroute, is helping Nakamoto-style currencies. So that is something we understand very well. And the next thing for us is to understand how bloXroute might help proof-of-stake currencies. I see proof-of-stake currencies coming over the horizon. I believe that in the next year or so, we're going to see all sorts of interesting currencies based on different consensus protocols. We might see classical consensus protocols. We might also see Avalanche start to gain prominence. And these are both approaches that rely not on work, but on stake. And in proof-of-stake protocols, so there are a whole set of questions for bloXroute to ask, which is how can bloXroute help them? And the bottom line, I mean, there are lots of interesting and nuanced issues, and if anybody is interested in studying them, they should apply to Cornell and other schools for graduate studies, because the topic is really exciting. And I don't want to get into too much detail and bore your listeners with the differences between hash graph style communication versus PBFT style communication. But with proof of stake protocols, we see interesting communication patterns, and there is so much to be done to make that process efficient. That's going to be one of the next frontiers for us. And at the end of the day, it's always going to be the case that somebody on the network will have very important, very timely info. And it's always going to be the case that there will be at least one, and often many, hundreds, if not thousands, hopefully thousands, maybe even millions, of people who want access to that information as quickly as possible. So So it's our goal to be that gap, to be that bridge, to fill that gap between those two sets of people, and I'm very excited about what lies ahead.
Now, Professor, you also mentioned Avalanche, so I wanted to give you a moment at the end of this interview to talk about what you are spending most of your time on, as well as what excites you the most.
I'm currently spending a lot of time on bloXroute actually because it's got its pre-ICO coming up. But my time, is split partly between Avalanche and bloXroute at the moment. Avalanche is in stealth mode, in heavy development, and we're very excited also about the innovations it brings to the entire picture at the consensus layer and on up. And to get back to the original topic, I think at the intersection of bloXroute and Avalanche lie a set of very interesting problems, because the communication pattern in Avalanche is unique, and bloXroute type approaches can provide huge benefits there as well.
And that wraps up another episode of the 500 BlockCrunch mini-series on scaling. Hopefully you've learned something new about layer 0 as well as block propagation. I know for a fact that I have, and I started thinking harder and deeper about what it actually means to scale a blockchain, as well as what the actual constraints we are trying to get rid of are. Now, if you haven't already, please do subscribe to this podcast on whatever platform you're listening to this on to make sure you don't miss another episode. And you can also follow me on Twitter at Mr. Jason Choi, that's MrJasonChoi. And I look forward to sharing more with you very soon.